you may ask questions. And you may do so in German. I will pretend to understand. Because the only stupid question is the one not being asked. What we are going to deal with tonight in my presentation will be facts, will be realities. So for that reason, it is not allowed to present any political statements. We'll be dealing regarding the questions. The questions should keep us on track. And on track is realities. And here you see two realities as they presented themselves to the world on December and preceding time, September 11th, 2001, the famous Twin Towers of World Trade Center. Now, background music. Now they were finished. This is the North Tower and this is the South Tower. And so it's important already from the start to be aware of the four corners of the world. This picture is taken from New Jersey. What you see here is the Hudson River. So those of you who have been scouts will know you have south to your right here, you have north to the left. On the other side of Manhattan is the east, and 6,000 kilometers we are sitting here and enjoying each other's company. Now the North Tower was finished in 1970. It was 18 meters high, and on top of it there was 100 meters TV mast. Such a tower, in terms of weight, amounted to, when I started looking at this, the consensus was 500,000 tons. And this number actually, surprisingly, is a matter of dispute. The lowest number I've seen is 250,000 tons. So let us put it around 350,000 tons. It's not so important. What is important, that 90,000 of all these tons were steel. This is important, as you will realize later on. The South Tower was finished in 1973, equally for almost half a kilometer high, 110 stories. And they stood there until the morning of September 11, when there was a French TV crew out in the street following the heels of a so-called rookie, which is a firefighter in training. And nothing had happened for a month. They were kind of bored. So this morning there had been an alarm of gas, smell of gas, in one of the small streets of Manhattan. So this is the fire chief actually for the station here, going out checking for gas. This is the one with the cap.
It was 8:46 in the morning.
And then we heard a plane come over, and in Manhattan, you don't hear planes too often, especially loud ones.
This was the North Tower, which was hit first at 8:46 in the morning. 17 minutes later, this thing happened.
We've seen it from the front angle before, but not from this angle.
Then 56 minutes passed by, and at that time, actually, the fire of the South Tower was dying out.
This is as close as we can get to the base of the World Trade Center. You can see the firemen assembled here, the police officers, FBI agents, and you can see the two towers. A huge explosion now, raining debris on all of us. We better get out of the way.
the same event in another video clip here.
To fall away from the rest of the building. Can we go to the tape now? Here we go, right here. This is, I mean, when you look at it, the building has collapsed. That tower just came down.
Let's go to Bob Bazell, who was at St. Vincent's Hospital. Bob.
So this was the South Tower, which went down first, even though it was hit latest. The North Tower was still burning, but as you can guess now, we are going to 1029. Those who know this game will recognize that the antenna goes down first. Again, I have this event in another video clip. This time it's taken from Manhattan. And it's impressive, actually. You could see how huge, enormously big these buildings were.
People coming from the city, folks stepping out of bodegas and stores for work. Now people are gathering in large groups. In fact, in one corner, I saw a group of people actually holding hands and praying. As I stand on the Manhattan Bridge, which is closed, it is open to pedestrian traffic. Some people are walking across, but there's just no way for them to. As I look at something else that I can't see,
Well, most of our fellow citizens do not know that World Trade Center consisted of 7 buildings, actually. And the North Tower is numbered World Trade Center 1, the South Tower is number 2, number 3, the Marriott Hotel was smaller, 22 stories, and number 4, number 5, and number 6 were all 3 of them also smaller buildings. But there was a gigantic building standing on the other side of a small street called Vesey Street. This picture is a live photo taken from the south. You have 1, you have 2, you have number 3 here, you have 4, you have 5, you have 6, and this is building 7, which was also a remarkable building. It was 186 meters high, 47 stories, and it had a ground floor a little less than a soccer field. The distance from the North Tower was a little more than 100 meters. It was much newer than actually than the towers. It was finished in 1987. And this picture is taken in between the time when the North Tower had been hit and the South Tower was not hit yet, where you can see the north facade of Building 7 was covered by this nice brown marble, actually is what it was. 20 minutes past 5, this thing happened.
It's gone, man.
17 down?
Building 7 went down just like that. It seems you have seen this before, haven't you? Okay. So then probably you also see that there are 2, 3, 4 other videos. This is from West Broadway Street, where you could see how tall the building really was. This is not a chicken shack in the backyard. This is really something. This has been taken with a big telelens from Midtown Manhattan. What you should realize, see here, is that the penthouse here went down first. And listen. Listen, it's weak.
It's amazing. Amazing, incredible, pick your word. For the 3rd time today, it's reminiscent of those pictures we've all seen too much on television before, when a building was deliberately destroyed by well-placed dynamite to knock it down.
Have you heard this before?
And
okay. Now, and it went down exactly and made a small, nice pile. It's 20 meters high, 2 stories high, without making hardly any damage on the building surrounding it. Maybe there's a little chunk was hidden off this building here. This picture is taken from the south, same situation, where maybe there's a little damage, but the other buildings here were barely scratched, and all what was left of building 7 was the steel panels, neatly arranged here. We call this scientist phenomena as an explosion, which is the opposite of an explosion. If you have a big pressure in kind of container, and it goes boom away. But if you imagine that you have lungs like Superman, and you're able to suck all the air out of a bad Coca-Cola bottle, it goes, and this we call an implosion. And this is what happened here, because all the core of building 7 went down first, and then the outer panel kind of folded in over it, making this nice little, so everything is nice and clean and neat when they were finished. You would appreciate that, I'm sure. So this is what was characteristic of building 7. It went down in an amazing speed, 6.5 seconds roughly. And what would Sir Isaac Newton have said to that? I met him recently, and yeah, it's the guy. Actually, we were discussing another matter, refraction in a prism. And he said, this is free fall. And now what did he mean by that? You know, he discovered gravity. And I'm looking now for something, which I can demonstrate free fall, because he came up with a formula in 1687. Actually, he waited 20 years to publish it because he was scared of the authorities. It's true. And this is because Galilei had been treated badly by the Roman Church 30 years earlier. Now, he came up with this formula here. We say that the height of freeform speed is 1/2. G is a constant called the gravitational constant. And don't be scared. T is squared here. But you can take your pocket calculator and you can put in 2 meters here, and what will the time come out? I tried that. It will be 0.66 seconds. So now I'll take this hairbrush, and don't worry, it has been through it before. So, and I will hold it at 2 meters above ground. I'll count to 4, but I'll release it on 3. 1, 2, 3. And it hit the ground before. I didn't say 4, I should have said that. But it was 0.66 seconds. Now this happened to the 47-story floor of building 7. When it started to fall, it fell as if there was nothing below it. If some idiot had been standing on the 47th floor holding an apple or a hairbrush out of the window and released it at the same time as she had begun to fall, the apple would have hit the ground at the same time as the 47th story. This is a very important feature of this collapse, that the 47th story fell as if there was nothing below it. All supporting elements was cut simultaneously at once. And how could this happen? This is kind of the riddles problems that we have today. I'll present to you a small video which demonstrates this. Now the ball here is free fall.
The ball has started to drop, yet 7 World Trade is still above the starting line. At the 1 second mark, 7 World Trade and the ball are still even.
Difficulties around the area. New Jersey Transit outbound.
7 World Trade indeed falls 100 meters in 4.5 seconds.
And you will appreciate that this video, actually, we were seeing the part of the building that we could see in the first video I showed you, which is the most honest way of doing it, because under these circumstances, you can accurately measure the distance from the building standing next to it, and you have an exact time of the event because you know how many frames per second there is in the video. So this is as accurate as can be, and there's no doubt about this fact. Furthermore, you will notice that Building 7 went down. The Americans call it sudden onset. It means that everything starts at the same time. And it fell completely symmetrically. We appreciate that. It fell all the way down. And for those who can remember how to count to 3, we should all recognize that there were 2 airliners, but there were 3 skyscrapers. So already there you should recognize, hey, there's something which deserves a closer look. Now, I have to limit this presentation because there's something other stuff I want to tell you. But when I do this, usually in Copenhagen, I spend a lot of time on a report by the National Institute of Standards and Technology, who came out with a final report on the collapse of Building 7 in August-September 2008. But the main conclusion from their part were that Building 7 collapsed primarily due to conventional office fires. You can spend a lot of time going through the facts behind this outrageous conclusion. But I'll just do a few remarks on this. One thing which is absolutely conclusive is that it has never happened ever that what we Americans call a steel-framed high-riser. That is a construction built around a steel skeleton. It has never ever happened that such a thing has collapsed due to fire. There's been between 400 and 600 reported fires in buildings like this. It has never happened that any one of these has collapsed. I could show you many, many examples. I have picked out for the occasion one specific example because it's very recent. This happened in Beijing here in February, not very long ago, that the Chinese were celebrated New Year. And they're very fond of fireworks, as you know. And this strange construction is the Chinese television headquarters in Beijing. And it looks, I'm standing too close, but the buildings here are normal high rises. So this is a gigantic riser, or whatever you would call it, is enormous construction. And what's interesting here is that they were building a kind of appendix to the gigantic headquarters here in the back, but this is no small thing either. It was 150 meters high here and 40 stories. And on the evening on February 9th, somebody were playing too well with the fireworks. So actually this one caught fire. The Chinese are not very happy about this story. If it was a little darker, you could see more details. But this is actually the whole building in flames. Yeah, that's better. In the night. This is what I would call a decent fire, right? The whole building was simply totally engulfed in flames. So they got their New Year fireworks in Beijing, and it seems maybe they have stored fireworks actually on the top floors. I don't know why this is happening. But here are 2 pictures. And now it's for you to guess which one is before and which one is after. Well, it's the one below, which is after. And this is a closer look. This is before, this is after, and this is the building after. This kink was supposed to be there. It's a piece of art. And so if the building was standing, of course the furniture and the carpets and all the other stuff was gone. But the building, the main construction, stood tall as a demonstration that steel-framed high-rises just do not fall. I have picked also a few pictures of Building 7 for comparison. This is about 3 p.m. in the afternoon. And you may think that I have been selective, but it is not so. I could talk for a long time to details the reported fires from Building 7, and NIST has done this very accurately, over 112 pages. So you could tell by the minute where and how much it burned in Building 7. And these were random small fires. These on the 12th floor, this is on the 7th floor. Here's another one for comparison. This is 20 minutes past 4 in the afternoon. We have shifted a little bit on the north side of Building 7, but these are random fires. And this is the other side of the Peking TV headquarters. And I just put these pictures in because I think they're pretty. This is a picture of Building 7 seconds before collapse. You can see here over on the right side that the kink on this wall is already coming down, and it's accurately timed here. The timing on this has been derived by NIST and certified to be seconds before the collapse, and there is no fire. So much for Building 7. Let us repeat.
Gone, man. 17 down.
Please speak out if you have any comments. We are okay. So if we should summary on the fire business, it's a fact that steel-framed high-rises just do not fall because of fire. And if this should have happened for the first time in history and 3 times on the same day, random small fires cannot cause one simultaneous sudden onset. If some of the steel beams would be weakened, wouldn't you expect the building to go a little down the one side first and maybe collapse partially? You would never observe free fall speed. You will never observe a complete vertical symmetrical collapse, and you will never go all the way down. So we can rule this out. So how did the buildings come down? We need a new hypothesis. This is basic natural science. If your hypothesis cannot stand to the data, you've got to find a new hypothesis. And to get an idea which direction we're aiming at, I'm quoting from the front page of the NIST report, a preliminary report. They call it an interim report from April 2004 on Building 7, where on the front page in yellow letters they wrote, I quote, NIST has seen no evidence that the collapse of WTC-7 was caused by bombs, missiles, or controlled demolition. Hey, bombs, missiles, who is talking about bombs and missiles? Nobody has talked about bombs or missiles. And what is controlled demolition? I'll show you what controlled demolition is.
Unbelievable. Whoa. On the top of that 12-story building, there's...
Excuse me. Turn it down, Vito.
gone, man. 17 down.
This is a famous picture, as you all know, probably by the Belgian painter. So our new hypothesis from now on is controlled demolition. And I'll tell you how to pull down buildings. If any of you are interested in natural science or have a son or a daughter who are interested in natural science and you want to learn how to take your grandmother's clock apart or split your father's lawn cutter, you can go to a nice website called How Stuff Works. And there are many brilliant articles on that. One thing is how to demolish buildings. It's a serious, very good picture. Actually, and the first thing what happens is, of course, you need the blueprints of the building. And the next thing is, these days, the demolition companies, they make three-dimensional computer models of the buildings, not only to estimate the load and the weight of the different components, but also because they can run the demolition like a simulation in real time. So they can see exactly what will be the impact of the charges they put in, how they should be precisely timed, which is very, very important in order to hit the footprint. And then, of course, they go through the building many, many, many times, because this is a piece of art. And it's an art which goes down through generations from fathers to sons. And so they go through the buildings and they evaluate, hey, maybe this pillar should have 3 kilos there, and maybe not. And to tip over a chimney, which happens, you see, it is the, what you call it, the local scouts who go out to put down a chimney, an old chimney. They put just a piece of dynamite here and they blow it and it falls this way. This is like taking down a tree. They don't count this as anything. But to hit the footprint is a very well-respected enterprise. And only very, very few companies in the world can do it on larger buildings. It's less than a handful. So what we have been witnessed here should be considered with respect. Now, I have chosen specially, this is a video I have never shown before in my presentations, but I have used this tonight because then we kind of don't have to discuss so much. It's made by a physics teacher called David Chandler, and it's downright brilliant in my opinion. Maybe I cut it when we've had enough because it lasts 5 minutes. But I wish I had a physics teacher like him. One thing is building 7, another thing is the towers.
The starting point in science is observation. What you are seeing here is what happened to the North Tower of the World Trade Center, the second of 3 buildings to collapse on 9/11/2001. I use the word collapse, but words can be deceptive. What do you really see happening here? There's a tremendous amount of falling debris, but under the canopy of debris, do you see the rapid sequence of explosive ejections of material? Some of the jets have been clocked at over 100 miles per hour. I will call them explosions because it's hard to find other words that describe what we are seeing here. The explosions are not isolated and few. They are continuous and widespread. They move progressively down the faces of the building, keeping pace with the falling debris. Perhaps you can imagine a natural cause, but I can't. Notice that the explosions are occurring on multiple floors at once, over a wide zone, not in a floor-by-floor sequence that might be explained by pancaking collapse. Notice there are explosions far below the point of collapse. Some are isolated and focused. These are often referred to as squibs and are commonly seen in controlled demolitions. However, this is not a standard controlled demolition. The building is being progressively destroyed from the top down by waves of explosions, creating a huge debris field. The destruction is in waves, not just in one wave. Most obvious is a rapid sequence of explosions near the visible corner of the building. But simultaneously, we can see another wave of explosions much further down the face of the building under the canopy of falling debris. Notice that both waves of explosions progressed down the face of the building, nearly keeping pace with the falling debris just a few feet away. Slabs of concrete did not fall to the ground and smash to dust. There was almost no concrete in the rubble pile. Notice that the concrete is being forcefully ejected outward from the sides of the building, already pulverized to dust. Notice that embedded in the dust clouds are huge girders and entire sections of steel framing.
I cut it here because I realized that we are late. Now, I think there's no arguments left after seeing this. The towers came down in a different manner than Building 7. Building 7 was more, I would say, conventional demolition, but the towers was just blown up from the top down, because a controlled demolition is controlled. Where's Manfred? Because it's 10 minutes to 10 now. Okay. So I'll tell you a little bit of chemistry, how you blow things up. Now, dynamite is a common word in the vocabulary, and this is very useful if you want to blow out concrete columns. You bore a hole, you throw in the dynamite, you light the fuse. But now to take steel columns down, you really need something more sophisticated, stronger. And one of the most common explosives is called RDX, or cyclotrimethylene trinitramine. So I have to brag a little bit. I know the formula. It looks like this. And the burning rate goes with 22, 23 times the speed of sound. So it goes through the sound barrier 23 times. So this is really something which hurts the ears. Now, there are explosives which are much more silent. But this is the most commonly used explosive for steel beams. And so routinely, when workers cut down steel beams, they mount it like this. These are two workers who are mounting what they call beam cutters. And it's obviously mounted at an angle of 45 degrees so that it's supposed to slide off once the explosives have knocked over the beam with the pressure. It's very important to appreciate that explosives work by pressure. It's like what you call it, a hit. And then someone has noticed that some of the steel beams on ground zero were actually cut in the same manner. But this is a disputed picture, and do not have time to go into the details about that. There are other means to cut a steel beam, and this is thermite. Now, thermite is not an African insect with 6 legs in my vocabulary. It is a mixture, and it can be various chemicals. The classical thermite was invented by a German chemist called Goldschmidt in 1893. And the first patent is from 1898. And it composed of a mixture of powders, pulverized, very finely grained aluminum, and finely grained iron oxide, also called rust. Now, if you can get these two components to react, and this is a powder mixture, if you could get them to react, you form iron, elementary iron, and aluminum oxide. Now, the iron being formed is very, very hot because the heat developed in this reaction is enormous. If you have a big batch and you just let it roll, you reach temperatures of 2,500 degrees. So the iron melt, and this is about 1,000 degrees beyond the melting point of iron, which is 1,538 degrees centigrade. Now, so you get some molten iron, which is very useful if you want to weld train rails or tram rails. It was used in Essen in 1899 for the first time, actually, to weld tram rails. But old-time thermite is not an explosive. It only generates an enormous amount of heat. And this iron can be used to melt steel, since it comes out so hot that it actually can melt other steel items. Now I will, as a demonstration, show you what thermite can do to a French car. Now this is an English, I would even say British movie, so it is slightly chauvinistic, but I hope you can appreciate.
This is Thermite. It's a powdered mixture of iron oxide and aluminium, which when ignited burns at 2,500 degrees Celsius, which is very, very hot. This is a car. It's been specially chosen to be destroyed because it's old, it's white, but more importantly, because it's French. The engine block is the densest part of a car. It's basically a huge lump of metal, and, well, it's very hard to melt. Lucky then, the Brainiacs have plenty of thermite, specially packed into the slow-release mechanism of a garden flower pot. A big pile on the bonnet directly over the engine block should do the trick. Time to light the fuse and give this homage to French engineering the send-off it so richly deserves. The irreversible thermite reaction begins.
Now watch out what happens here below the car.
Within seconds, the fiery concoction eats through the bonnet, spraying molten thermite into the engine beneath. The devastation continues inside until finally a torrent of white-hot liquid metal pours out of the bottom, signalling the inevitable victory for thermite. A quick check confirms a clear path of destruction through the engine.
Yeah, this is how we teach chemistry at the university. Now, so what happened here is the thermite. So the molten iron goes, all the way down through the multi-block. And so many people and so-called 9/11 debunkers have noticed that a thermitic mixture, a thermite, can only work, the molten iron is produced vertically. So you can never blow a vertical steel beam. How can you melt a steel beam? I'll show you. The next film is a commercial thermite, which you can buy. And I have to tell you up front what you're going to see, because this is so short that everything happens so fast that you hardly get a chance to recognize that the steel beam actually has been, or it's a small steel beam, has been blown over. What you'll see is the small thermite is mounted horizontally. There are two wires going out from the end because it's controlled by electricity. And this ad has been removed from the web, but a friend of mine had it on stock. It's here. That's it. That's how you do it. And the point is that there is a so-called propellant behind the thermite mixture which blows the thermitic mixture out horizontally. So it can easily be done. I also have military patents where they are packing these horizontal thermites into batteries like what you call ein Stalin-Orgel. What is this, German? Okay, where this is also Danish. So where you can actually blow holes. This is not a problem. There are other means to have it work on vertical beams. So the debunkers have lost that game. Now, what we should go through, yes, I should say, if you ever want to burn down your house while you're on Gran Canaria, this is the way to do it. Because you can pre-program, of course, these thermites to go off while you're away. And according to some American, there is what you call it, instructions. When the police has suspicion that this is arson, this is the English word for when you burn down a house intentionally, they have to, according to the law, they must check the remains for thermite. And the trace the thermite leaves behind is very easy to see. So, and this was obviously not done after 9/11. Now, one of the evidence, I have 2 or 3 evidence, some of it I'll skip. The most obvious things is the appearance of molten iron. And this is a video I'll show you. of the South Tower, and I have to warn you because the sound side on this video always hit me in the heart. At this time, nobody knows what's happening. It's an amateur who accidentally is filming this liquid metal pouring out of the 82nd floor on the South Tower. What is this? What's happening here? There's no cut in this movie. It's real time, which is important for the time scale. Remember, at this moment, nobody knew what was going to happen. I have a still picture of whatever came out of this, and it's very important that it has an orange glow, which means that this is not aluminum or aluminium, because molten aluminum is silvery or white. There's no doubt that this is iron. Also, there's no doubt that molten iron cannot be produced in an ordinary office fire. There's no way you in an office fire can reach 1538 degrees centigrade. So this is molten iron. Furthermore, in the slag, in the remains in ground zero, for weeks after, there were discovered obvious pools of molten iron. This picture has been taken 8 weeks after 9/11, and the workers, whenever they dug into the remains, there came molten iron up. I have many pictures. I have counted 22 witness reports on this here. Here I put a thermite reaction from the lab to suggest something. And this picture I do not know when it was taken, but I think it's very impressive because this remains a picture from my childhood geography books, ein Hochofen, a blast furnace from the Ruhr area, right? This is what it looked like. So something is happening in here, and but I don't know what it is. Yes, I know. Now this is a thermal map of ground zero. It is not a geographical map, but NASA took an airplane and flew over ground zero on September 16th and measured the surface temperature by infrared light. And the color code means that this is the North Tower, this is the South Tower, this is Building 7 over here. The color code means that the surface temperature here was 750 degrees centigrade. And this is the surface. And over here, it was 730 degrees, and 750 down here. In spite of, in the days in between, on September, I think it was the 13th and the 14th, it was pouring showers. It was raining, it was very heavy rainfall. Still, the surface had these tremendous temperatures, which is beyond what will occur in an ordinary office fire. Now, if we can, despite there's a little shadow here, but it should be September 23rd, a week after it has cooled off somewhat. But as you can saw from the other pictures, way down below, and for months, actually, there were molten metal recognized under the film. Many witnesses. I have counted 22 witness reports of molten iron. It has never been seen after fires. It is not mentioned in any of the official reports, and the NIST representatives, they just defy, is this a problem? They deny any existence or knowledge of molten metal. They simply refuse to acknowledge it. Now, I call the ground zero as the longest smoking gun in history. which can, of course, you can play on this one. But the fact is that the fire was not put out before September 20th. Some sources say December 13th or December 14th, but it's a fact that it took 3-4 months to put out this fire. So this was not an ordinary fire. And they were pouring tons of water on. And they even applied an artificial fire suppressant called pyrocool in order to cool the things down. But it happened that each time they dug into the pile, there was an eruption. So the reason why it took so long is that the remains kept on reacting. It was a bitch's brew. It kept on reacting underground fire. And I could talk for a whole hour about this because Kevin Ryan has studied the exhausts, the air pollution and the reports, and there's a lot of strange stuff coming out in spikes, in eruptions, very suddenly over 1 or 2 days. If anybody you is interested in chemistry, there was enormous emissions of benzene, toluene, ethylbenzene, styrene, and a very interesting compound called 1,3-diphenyl propane. And this has never seen ever before from a fire. And we believe, I'll tell you where it comes from. Now to the dust. Maybe that's why I'm here. I put in this picture to show these enormous amounts of dust because everything within the towers and Building 7 was pulverized. Everything, except for the steel beams. That means that we were down to, most of it was millimeters. I'll show you some sample later on where there are bigger lumps also. But everything was crushed, I should say. And this is a picture we show what daily life was on Manhattan. What we see here is a layer of dust lying all over south of Manhattan to the thickness of about 10 centimeters. So people was waiting, and I promise you, this is not very healthy. So this woman was very clever that she kept in. This is another picture of a day in rescue workers' life. I guess this must be Deutsche Bank, which was hit here. And I shall tell you a story about a woman called Janet McKinley. I have showed this picture before. She lived on Cedar Street, which is this street coming up here, and Liberty Street. I think it's on this corner. At least she had a view to the plaza. And she lived in her apartment here. And so when the South Tower came down, she was in a hurry to get out. She was clever enough to take a towel and wet it and pull it around her neck, her face, cover her mouth, and run. And she was allowed to come back after a week. And this is what her apartment looked like. There were lying dust in abundance, a thick layer all over. And this is one corner of her apartment. Now, what I think is a beautiful aspect of this story is Janet McKinley was an artist, or at least she has an artistic itch, because she collected some of the dust in a plastic bag with the intention to make a piece of art. And as the story goes here, it ended up as a piece of art in a sense. She stored this bag, and a couple of years later, for reasons that you'll understand, a physicist called Stephen E. Jones got interested in the dust, because obviously we have already seen good reasons to believe that thermite was involved, namely the formation of molten metal. So already at this point, there was suspicion in some people's minds, among them Stevens, that thermite was involved. Another thing is that a report had emerged in 2003, in September 2003, from a company called the R.J. Lee Group, where they were making kind of, what you call it, signature they were characterizing the dust for commercial reasons. So, and what they found, I'll show you in a little while. But here is Stephen taking a look at the dust, and you can also see how natural science can be, because this is having studied natural science can be a party. And here he's discussing with some gentleman. Do you recognize him? This person?
Yeah, I think that's Hamuk.
Who?
Looks like Hamuk.
Okay.
Works with Ken Jenkins, my videographer.
Okay. At least they're discussing the dust, obviously. Here's a closer look on it, where there are bigger chunks. And what you do now is you take out the big chunks, and then you put the remains in a plastic bag here. You apply a very strong magnet to the plastic bag, and you pull it along the plastic bag, and when you get it up off the top over here, something follows the magnet. And you know, whatever follows a magnet is magnetic, or can be magnetic. And so, and what came out with the magnet here, you can see a picture of. This is from Kevin Ryan. And this is an optical picture here. This is the ordinary dust. This is what come out with the dust. And there are some white remains. There are some round, small spheres here and here. And we'll first take a look at the round spheres coming out. And as I pointed out, this was discovered already or reported on with no comments from in December 2003. One of the reasons why Stephen E. Jones got interested in it. And here are pictures. This is what Stephen E. Jones saw when he put the magnetic extraction from the dust under an electron microscope here on the left. Some of the stuff is not interesting, but this is round, perfectly round. We call them spheres, electrical spheres, and here is a close-up of one of the spheres. And this is iron. Maybe I have a better picture of this. Yes, here. This is the same picture I showed you before, and this is what you get out when you burn an ordinary thermite. I'm mixing up things now, because for identification, to see what's in there, one thing is magnetic, so there must be iron. But you can run something which is called energy dispersive spectroscopy, which is kind of a fingerprint of the elements, the Grundstoffe in the element. And you should not go too much into detail of this. Just recognize that this is from the dust, and this is from a commercial thermite, which you can run in the laboratory and you can buy. You can buy it anywhere because it's a very useful thing if you use it properly. There's iron here, and there's iron there. There's silicon here. There's silicon there. There's a little aluminum here. There's a little aluminum there. And otherwise, there are other elements which are less important. Now, the point here is that this is kind of identification, means that these spheres resembles very much the spheres coming out of an ordinary thermite. And an important point here is the fact that they are round, because a piece of iron can only achieve this shape if it has been molten and if it has been up flying. This happens to a drop of liquid once it is suspended in air. If you can take a closer look on water particles in a fog, you will see that all the tiny droplets are round. Or if you can take a look on in your skimmed milk, and see all the small fat particles there around. And this is due to a phenomenon called surface tension. This is what the liquid does when it's flying. So this iron has been molten and it has been up flying. This in itself is a very good proof of the presence of thermite has been involved. This chip, which Dr. Stephen E. Jones presented to the world audience on December 15, 2007. And this was symbolized the start of a scientific investigation into these chips, which had started a few months earlier, obviously, when Stephen discovered these chips, and brought together a group of scientists who by virtue of the internet, has worked on this, and it ended up in a communication, it is not a communication, it's a genuine scientific paper over 25 pages, which emerged on April the 3rd in a journal. And this is the front page, and I'm very proud to be on the list of authors, I must say. What I could do twice, two things. Either my original plan, if I had had the opportunity, would be to go through the evidence contained in this paper. I'm not going to do that because I have been asked instead to give an explanation on what this is about nanothermite. The point is that we have found active thermitic material, and I've already told you what a thermite is. It is something which, the old-fashioned thermite, can develop a lot of heat. And you have probably heard something about nanothermite, and these are some of the pictures of the chips which was found in the dust. The 4 different samples. These are each an example from each of the 4 samples. So it was found in the dust all over Manhattan. This is an electron microscopic picture of the chips. To give you an idea of the dimension, this is about 1/10 of a millimeter. So this is the thickness of these chips. The red side of the chips here emerge as white because this is an electron microscope picture. So the colors doesn't count yet. This is something about the physical characterization of the chips. The dimensions are very, very small. Please notice down here that this is 1/1000th of a millimeter. So let me just shortly tell you the ingredients of the chips. These, we call them flakes, are aluminum flakes, and these small white particles here are the iron oxide. This is the rust. As you have learned, are the main ingredients of a classical thermite. I'll tell you much more about this later. And the point is here, these color displays reflect different elements. This is aluminum, this is silicon, this is iron, this is oxygen and carbon. And the point is that this flake here is identified as an aluminum. So you characterize the chips physically, means that you are telling what's in there. And the chemical characterization is based on reaction, because chemistry deals with the transformation of matter. Chemistry means action and reaction. And here you see the experimentalist exposing a tiny torch to a chip, and those who are close enough can see a small yellow flame sticking out from the left. And this is the key point. This is the reactivity. The chips are active. And this is a microscope picture of the same process. This is difficult to get, I promise you, because the chips are small. But the most important thing is that when the chips have reacted, you can see the same iron spheres being formed. This is from the WTC dust. This is from a flame this is found in the dust. This is an active chip which was subjected to the flame, and well, it resembles quite a lot. I go through this very rapidly, I must say, because I have something more for you to learn later on. This is Kevin Ryan, who's one of the authors who has a laboratory. There is something published on how to make this material, and he made a batch of it actually, and this is what it looks like when he had finished, and this is what it looked like when he had it reacting, so his batch was okay. This is the same picture of the WTC red chip, and now maybe I should go rapidly through this, but this is an instrument where you measure, the temperature history when it reacts. And this is our chip. And the point is here, this spike is very narrow and it goes very high. And this is the only published corresponding measurement of an authentic chip. This is a guy called Tillotson from the Lawrence Livermore National Laboratory in California, who did publish this recipe and make this one. Okay, and this is the most important result in the paper, because these are pictures of the chips after they have been subjected to this, what we call differential scanning calorimetry. This is the instrument where you heat the chip. And before the heating, there are no such of these iron sphere there, we promise you. This is, and after the reaction, it looks like this. And this is the Nano, this is the remains reacted chips from Kevin Ryan's batch, where he had tried to make the Nano Thermite in his lab. We are pretty sure that this is not the same stuff, but it's close, and it is the only recipe being published, and it is based on the same techniques which I'll describe for you in a little while. Okay, and this is just a spectrum which proves that the spheres forms from the reaction contains iron, and there's no aluminum there. Now, I think now I'll switch actually to a small chemistry lecture which I made up for you here. And so now, if you're ready for some a pure, genuine chemistry lecture, because I have been told that some of you would be interested in actually to understand what nano thermite is compared to the ordinary thermite. What is the key point in nanotechnology? And this is the following. Now, energetic materials are materials which can do something violently. And we all know what a campfire looked like. And what happened in a campfire is that the wood, or it's coal or charcoal, is burning. And we all know that burning means that it is reacting with oxygen in the air, and you form carbon dioxide. This is a basic energetic reaction. And the point, actually, carbon in this reaction is more energetic than TNT, which is the most known explosive. This is the unit of explosiveness. You say that this atomic bomb corresponds to so and so many megatons TNT. I'll show you the formula in a little while. Now, the point here is that carbon is very, very energetic. No. This is what some of the debunkers say, that carbon is more energetic than the nanothermite. This is not true, and this is the point. It is the system carbon and oxygen which develops more heat than when TNT is exploding. Actually, 8 times more. So why is carbon not an explosive? Well, it is. If you have the carbon dust in, say, in a coal mine, we've all heard about exploding coal mines. So if you have very, very, very fine carbon particles and you mix them with air, they explode very violently. And this also happened in grain silos, silos where you use empty grain silos. They can explode if the carbon is finely divided. But in most cases, they burn like logs. And what happens there? Now, this is chemistry elementary course. You move electrons from the carbon to the oxygen. And the reason why it takes so long time for the wood to burn is that it can only react on the surface. So this reaction is limited only by the axis of oxygen, because the logs have dimension. It can only react on the surface. And we all know that when the fire is going out, what you have to do is to blow on the fire in order to get more oxygen into it. So this is the limiting factor on every fire. It is the action of air. And this is why flight fuel can never get hot enough, because the point is that you could not get any oxygen air through the windows fast enough. But this is another story. The towers, the what you call it, the flight fuel, yes, the kerosene, but there's another better word for it. Jet fuel could never melt the steel beams, never ever, because it's the axis of oxygen which counts. Now, let's take another example. This is gunpowder, which was invented by the Chinese in the 9th and 8th century, more than 1,000 years ago. This is a mixture, it's a powder, gunpowder, and it's a mixture of pulverized coal, charcoal, and sulfur, pulverized sulfur, and a substance called saltpeter. It's also called saltpeter in English, and actually this area of the world here in south of Germany and the Alps was the only places outside China and India where you can get saltpeter from mines in the Middle Ages. So what did they use in other places? They used chicken shit and as a source of saltpeter. But this is what you mix. And what happens, don't be scared, it's not dangerous. This is a chemical reaction, because you have the carbon and the sulfur reaction with the saltpeter, also called potassium nitrate, kalium nitrate. And it forms gases. This is very important. It forms carbon dioxide, sulfur dioxide, nitrogen oxide, and nitrous oxide. This is the chemical words. So gases are produced very fast, high pressure. And this is how an explosive works. It forms very high pressure, very fast. Now, it's the same game here, that electrons are being moved from the carbon and sulfur to the saltpeter. And let us see how gunpowder works. These are some German students who are making a potato gun. They have produced gunpowder from an old recipe, and they have a lot of fun shooting potatoes out of a barrel.
Jetzt. Ja, komm der Sache näher. Echt?
Now this little cannon really had to get rid of something, okay? And but the trick, maybe I should. Well, the point is that gunpowder is not very efficient. Actually, it's a little miracle that you can. What happened there, in my opinion. Then, for about 1.5 years ago, they started to invent other kind of explosives. And here are 3 formulas which you know by their standard knife. This is dynamite, which is Nobel found out how to handle and earned a lot of money. This is the TNT, and this is the RDX, which I showed you earlier on. Now the point here is that the 2 components which in the gunpowder react as a powder, yes, I'll show you here. I go back to the gunpowder. Now the electrons are being transformed from the carbon and sulfur atom to the nitrate. And these are particles. Here you have a carbon particle, and you have a saltpeter or sulfur particle. So you have to transfer electron from one particle to another. The electrons has a long way to go. Now I have switched the formula. I've just rewritten the formula of saltpeter for you to recognize the NO2 unit, because this is exactly the same as you see in nitroglycerin, trinitrotoluene. You see the NO2 unit here, and exactly the same thing happens when you, in these kind of explosives, you have to move electrons, but in this time, the electrons do not move from one particle to another. It moves within the molecule, which means that it had much smaller distance to pass. And this is why modern explosives, and there are thousands of them, are more efficient than gunpowder, and gunpowder is out. That's why you use trinitrotoluene, because the two components of the reactions is in the same molecule, and the electrons should not move very fast. This is an important point. The electrons should not move very fast. So let's sum up. Energetic materials, the monomolecular materials, we call them in one molecule, they are fast, but the energy content is actually very, very low. But because they are so fast, they can be used as explosives. Now, composite energetic materials like coal, it contains the reaction between coal and oxygen is 8 times more energetic than TNT. Recently, there's been a 9/11 debunker who had pointed the attention on sewage sludge. I don't know what you would call this in English, excuse me, in Germany. Could you? This is what is Kloakschlamm. Yeah, something like that. And it turns out that it shows kind of the same temperature curve actually as our nanothermites, because it's basically coal. It's very finely divided coal, so it has the same energy content as coal, and so they say that all our sewage is going to blow up because ha ha ha. But it's true, there is a lot of energy in sewage sludge. The point is that it cannot react very fast because it is a reaction with the atmospheric oxygen. So and this also goes for thermite, because these are particles where the aluminum has to react with the iron oxide as particles. These are slow, and gunpowder, which is not here, should have been here. Gunpowder should have been here. Is also slow because the energy has to work on. But it contains a lot of energy, but it cannot be used as an explosive. So we go back to the thermite. I repeat here the reaction between aluminum and iron oxide, which forms iron. Now this is the same transport of electrons from the aluminum to the iron oxide. But the ordinary classical thermite reaction is slow because the transport is between particles, and not like dynamite, where the electrons are moving within the molecule. Here they have to move between two macroscopic particles. So old-time thermite is not an explosive. Now maybe we can illustrate this with, here you have summary, this I should have shown earlier. These are the classical explosive, and here are the powder mixtures, which are slow because the particles are big. Now suppose you make the particles smaller, and this is what happens when you go into the nano regime. Ordinary, very good thermite, there the particles are the range from millimeters to micrometers, and micrometers is 1/1000th of a millimeter. Now, as you make the particles smaller, you can see up here, you have coarse powder, medium powder, and fine powder. Then the energy content is the same, but the point is that the reaction is much faster simply because the distance that the electrons has to travel from the iron oxide, which are red, and the aluminum, which are white, is much smaller. This is one important point of nanotechnology. So the reaction rate actually goes up with a factor of 1,000. Another thing, and this is an even more important point, it's not only a matter of size, it is also a matter of how the nanothermite is made. Because if you are to make something small, there are two basic but genuinely different approaches, methods. If you have to make something small, you can start with something big and then remove something, or you can chop it up. This is what you do when you grind corn, or when you take your salt between your fingers and you crush the salt crystals. But you can, and we call it the top-down approach. We start with something bigger and make it smaller. But you can also go what we call from bottom-up approach, which means you start with something even smaller, which in this case is atoms and molecules. So I shall try to explain to you what a sol-gel technique is. It is a means of making a composite material where you have a sol is a suspension of very, very small particles. And these are nano-size. And they are floating in a liquid. This is called a sol. Now, if you, by some chemical reaction, can combine the very small particles into a grid, you have made a gel. And we all know the word gel from the bathroom because this is something you put in your hair, and it's something slimy. Yes, and the wet gel, so the wet gel is a very intimate framework on a nanometer time scale. And with this, you can either exchange the liquid where you get something called an aerogel, or you can remove the liquid and you get what you call a aerogel. The point is here that now these tiny, tiny crystals you can make in a chemical, well, no, this is the material you get out of it, and these are very porous, and you have made such a tremendous framework of something. In order to make the nanothermite, this framework is the iron oxide. And don't be scared, because these are some chemical reactions. This is a chemical reaction which shows how you, from atoms, can build the iron oxide framework. So, and you can mix it with into this, you can put another framework which contains silicon. So you have two frameworks intervened. Now, if you into this framework, while you make this framework, which is one component, this is the iron oxide. This is not rust particles. Instead of having individual particles, you have kind of iron oxide all over. And in this framework, you then put the aluminum particles, and this is an electron microscope of such a composite material, and this is 25 nanometers. And 1 nanometer is 1/1000th of 1/1000th of a millimeter. So take a millimeter, divide it into 1,000 parts, and each of this is a micrometer, and each of these you divide into 1,000 parts. Then you have a nanometer. It is very, very, very small. And this is 25 nanometers. So you see these aluminum particles that you have here is about 25 nanometers. And they are embedded in an iron oxide framework. And it is symbolized over here. So you have the iron oxide framework, and you have your nanometer-sized aluminum embedded within the framework. This means that this is on the threshold between macroscopic particles and molecules. It is really molecules and macroscopic particles emerging. And so it's a genuine, this is not old wine on new bottles. This is a genuine new frontier where you bring the reaction partners so close together that the distance they have to travel is comparable with the molecular materials. And now you have the best of two worlds, because you have the high energy content of the thermite and you have the high reaction rate of an explosive. Furthermore, when you do, and this is another picture about the same thing. Actually here the iron oxide particles are down to 2 nanometers, the aluminum particles are down to 1 nanometer. Now, due to the procedure I sketched for you, you also have the option, when you do the reaction, to throw in polymers. And because the temperature, and this gives you the option to throw in other stuff which can develop gases. So I will not go into detail what these polymers can be, because there are a whole range of options. But the point is, because, not only because everything is much smaller, but because you make the nanomaterial in a different way. You're not just mixing sugar and flour. You are building the material up from bottom. you can throw in other stuff. So when you get these temperatures of 2,000–3,000 degrees, this other stuff will produce the gases, and then you have an explosive. So the potential of nanothermites is to act. It can be an explosive, or it can just develop heat. And the red chips we have found in the dust, we do not know actually what their action is. I showed you this film about the metal pouring out of the South Tower minutes before the tower fell. What I believe is that this is thermite which did not act as an explosive, but it was cutting the beams plenty of time, because when it works as a heat source, it's slow. But for the timing of the collapses of the tower, you need charges which can go off and ignite it in microseconds, which is 1/1,000,000th of a second, or milliseconds. The film I showed you with David Chandler, where you saw the waves of explosions going down the towers. These have to be timed so precisely that you can only be struck with awe actually for the pure technology masterpiece of this event. And so you have the option of thermites. It can either be an explosive, or you can use it as an incendiary, we call it, just developing heat. And we don't know yet. We'll do more research and find out. So what I don't have the original, but I can show you a copy of a website here, where this is a copy of the website, so it's not very good. But here they're selling nanotechnology is grabbing headlights for its potential in advancing the life sciences and computing research. But the Department of Defense found another use, a new class of weaponry that use energy-packed nanometals to create powerful compound bombs. And the selling punchline is smaller, cheaper, and nastier. But later in this article, he complains that it's very hard to persuade Pentagon to change their ways of killing people. So they're not selling as much as they believe, but these are the explosives of the future. I hope that I have communicated to you a small sense of what nanotechnology, what we believe, how it contributed to the collapse of World Trade Center, and why it took them 4 months to put out the fire, because this was never finished. It continued to react. And we have recovered some of the unreacted stuff. I have different means of ending my talk. I have selected this one specifically for tonight, because this is the goddess of justice, and we call him in Danish, Justitia is her name. She's blindfolded, and she has a balance, and she has a sword. And so justice is blind. I wish that science would be just as blind, because we should base our conclusions only on solid evidence and observations. So natural science is blind too, but it is not stupid. Thank you for tonight.
Thank you. I mean, just, not being a chemist. This is really stunning, and I'm amazed, because this is very, professional. And in order to create nanothermite, I mean, you need to be very educated. I mean, this is not something which a terrorist could just do like that.
No, I could quote Richard Gage on this, because he had said very exactly that this stuff was not made in a cave in Afghanistan. It was made on laboratories, military laboratories, and it's still secret. It's very hard to get information on it. And what they publish is definitely not the stuff that they use.
Can you explain why these chips are two-colored? On one side red, on the other side
No.
gray?
No. We don't know. The gray layer composed of iron and oxide, and not coal and iron and oxide. It's composed of iron. It's iron oxide. We don't know why it's there. And we don't know either actually why we recover any thermite at all. What I anticipate is that in the reaction, when it goes like that, some of the outer shell has been blown away from the reaction zone, so it's not taken in. But we don't know. We don't know what the gray side, why it's there. Maybe it's packaged, or maybe it's because it has been inherent to something, or maybe it's support, or we don't know.
You also mentioned that they probably put in 50% more than needed.
Well, this is my personal feel, because once you start digging into the event of that day, you start realizing that this should not fail. And this was when I realized that there was no pilots in the planes, because the logistics on that day is so comprehensive that it just couldn't fail. But imagine these guys at work. Building 7 is 30% higher than any building ever demolished under control. And the towers are 3 times higher than at that time the world record for demolition. And there were no rehearsals, I promise you. There were no Generalprüfung, I don't know the English word for Generalprobe. There were no replays. There were no say, hey, let's take it over, let's take it once again. No. So if I was in charge of the operation, once all calculations had been done and everything timed on the computer and stuff, I would throw in 50% of the good old stuff, which I knew would work. And I believe that this is why we see these fantastic pictures where the towers, they don't collapse, they just disintegrate. They're blown apart in air. They overdo it. I would have done the same thing. Overkill, yeah, I would have done the same thing. I mean, imagine it has stopped halfway down, and it would be so embarrassing.
So, thank you for this presentation. You say in the video, I have seen it on your blog, that you 10 to 100 tons of material have been moved in pallets for this firework. And my question is, how long you think, what amount of time it needs for the preparation? How do you apply it? Do you have to do lots of drillings? Is there a lot of labor involved to, if you have to put 100 tons of stuff all over the place? Has it been on every floor, or how has it been done practically?
I don't know. I usually don't go into speculation. And this is the basic principle of science, natural science, that you should not carry your conclusions beyond the data. We have collected these data here. I will answer it. Don't worry, I'll answer in a little while. But we have collected these data, and from the data we have drawn some conclusions. And this is where our job ends. There's a lot of speculation of how it was performed. And also because this nanothermitic material, you can actually paint it on and spray it on. And I don't believe in that. Now this is my personal, now I'm guessing, I'm not a scientist anymore. I believe that you have had charges, genuine charges, put on strategic places in order roughly every third floor on the way down. This is what you need in order to have a free fall collapse like Building 7, every third floor roughly. You have to cut the beams into pieces like that. Regarding the towers, I don't know. What I say, this stuff should not have been there. Whoever put it there should tell us how, why, and when it got there. I have no idea. Pardon?
A lot of labor involved to place it.
Oh, thousands of people have been involved in this.
Maybe I can explain something.
Please.
Also, um euch ein bisschen zu zeigen, weil die Frage im Raum steht, wie kriegt man 100 Tonnen in dieses Gebäude? Der World Trade Center Komplex hat 50.000 Menschen beherbergt. 50.000. Das ist also eine große Stadt. Jetzt stellt euch eine Stadt von 50.000 Menschen vor, was da an Warenverkehr stattfindet. Da waren hunderte Lastwagen, die jeden Tag unten reingefahren sind. Das war wie auf einem Frachthof. Die haben jeden Tag 100 Tonnen Waren reingefahren. Und von dem wird nichts kontrolliert. Denn das sind in Containern, auf Paletten verpackte Waren gewesen, Papier, was immer die da reinbringen und wieder rausbringen. Die einzige Sicherheit, die ja war, waren die Personen, die liefen durch den Scanner. In der Lobby, das habe ich erlebt, wie am Flughafen. Aber die Ware unten im Keller, die wurde tonnenweise jeden Tag reingefahren. Deswegen die Frage, wie hat man überhaupt 100 Tonnen oder wie viel reingebracht? Ja, das ist ganz einfach, man hat sie einfach angeliefert. Da stand sicher nicht drauf, Nano-Thermit zur Sprengung der Türme. Oder? Das war halt irgendeine Ware, da steht drauf, Lieferung 25. Stock, peng, fertig. Und dann ist das dort gewesen. Außerdem wissen wir ja, dass es Renovationsarbeiten gab, um die Feuerfestigkeit zu verbessern. Arbeiten vorher. Wir wissen, dass der Strom abgeschaltet wurde eine Woche vorher. In den gesamten Türmen wurde der Strom abgeschaltet. Wir wissen, dass sehr viele Handwerker Wochen vorher unbekannte Arbeiten gemacht haben. Also, außerdem kann das Ganze sehr lange vorher geplant sein. Das kann Jahre vorher geplant sein. Also das da reinzubringen, das ist wohl das Einfachste. Und auch das Verteilen. Das kann ich gebe euch ein Beispiel. Wenn ich ein Dieb bin und ich will ein Gebäude ausrauben, dann mache ich das nicht so, wie man das in dem Klischee sieht. Ich tue mich schwarz anziehen und komme in der Nacht mit einer Maske. Sondern ich komme am Tag und bin ein Handwerker. Weil wenn ich in diesem Gebäude rumlaufe mit meinem Gürtel, mit meinen Schraubenschlüsseln und alles, bin ich dann verdächtig? Nein, das ist ein Handwerker, der kommt, so wie man sie immer sieht. Also so macht man das. Das ist alles einfach. Viele Leute tun sich sehr, sehr naive Fragen stellen. Auch die Frage, wenn viele Leute da involviert sind. Jeder, der im Militär war, weiß, dass nur die oberste Führung weiß, um was es geht. Die ganzen Leute unten, die wissen nur, ich muss von A nach B gehen. Ich muss diesen Hügel stürmen oder ich muss diese Position halten. Warum sie es machen müssen, in welchem Gesamtplan das drinnen ist, das wissen sie nicht. Das weiß höchstens der General und seine Adjutanten, aber sonst weiß es niemand. Und vielleicht erzählen sie sogar ihren Leuten ganz eine andere Geschichte, warum sie was machen müssen. Wir dürfen nicht vergessen, an diesem Tag liefen mindestens 5 Militärübungen. Das Ganze wurde getarnt in Übungen und so mache ich das. Ich mache eine Übung und schalte dann auf Live. Und zum Beispiel in London, bei den London-Bombing war es ja auch so, war ja auch eine Übung. Wir müssen nur beweisen, dass die Story nicht stimmt und nicht, was könnte irgendwo sein, wo sind die Flugzeuge, wo sind die Passagiere. Das ist alles Spekulation. Unsere Aufgabe ist nur zu sagen, das behaupten Sie und das können wir gegen Beweise bringen. Und dann hört es auf. Denn unser Auftrag ist nicht darzustellen, was wirklich passiert ist. Wir müssen uns endlich von dem lösen, dass wir beweisen müssen, was wirklich passiert ist. Das müssen wir nicht. Wir müssen nur sagen, das sagen Sie und das haben wir festgestellt und das stimmt nicht überein. Und damit wir eine neue Untersuchung bekommen, diese Untersuchung muss dann die Macht haben, die Leute unter Eid zu nehmen und sie auch dann zu bestrafen. Wir können doch zum Beispiel niemanden vor ein Gericht bringen und unter Eid aussagen lassen. Das können wir gar nicht. Das muss eine Kommission machen. Und auf die müssen wir hinzielen.
Just a small question. Why took it so long, 2 years, from the finding until you have found your research?
This is science. This is the time it takes.
You showed us that you found a significant amount of nanoparticles in the dust. And from your point of view, there's no other possibility. It must be nanothermite. Is it right?
That's correct.
Okay, and what are the reaction of your colleagues from the chemistry and also from maybe from the government? I don't know.
Well, my colleagues, scientists, are like all other people in average, and they don't know. This is the great majority of people, they don't know anything. And out of them, the great majority, out of those who know, the great majority don't care. But that said, I must say that in the start, they were rather hostile, fiendlich, of my colleagues. Yeah. But at some point, I had the opportunity to present the evidence. And from that day on, everyone is smiling at me. And even my boss is, I have had a conflict, but when he saw the evidence, I must say to his virtue that they respect the evidence. They don't stand up for me, and they don't go to the press, but they smile. And they respect me, yes. Thank you.
Okay, I have one more question, please.
Please.
A small one. Many people say, okay, these dust samples could have been from everywhere, but I wonder whether such kind of chips are still in New York. I'm sure that not everything was cleaned up. I'm sure that the chips are still in the earth or in the sink or everywhere it should be, isn't it?
Yeah.
So it would be easy to prove that still there's some chips there.
No, not easy.
But it can be proven.
It's not easy. Actually, I'm surprised that they're still active after all these years. And one of the pictures I showed Kevin Ryan had taken, it's not enough just to extract the magnetic material. Many of the chips are not active anymore, and it takes experience, which Jones is the master of this, to say, now this chip is going to work, this chip is not going to work. He has specific criteria for whether he can recognize the active chips. So, no, it was cleaned up, and what we're looking for people who have saved some dust in plastic bags. And there's a guy in New York who stands on ground zero and say, if you have some dust and you want to investigate it scientifically, please call me at this number. He's being harassed and chased by the police. Denmark is a little special because I had arranged for the launch of these news with a science website called Wissenschaft.dk in Danish. So he was ready, so actually it was launched internationally within hours when the paper would come out. But this was Friday night. It couldn't be worse, at 9:30 in the evening. And at the same time, our Prime Minister was elected Secretary General of NATO. So he took all the headlines. But still, this was communicated to the Danish newspapers, and most of them brought the story on their web editions. Nobody brought the story in the printed versions of the papers. But many did it on the web editions. And then one TV station took me for an interview on Monday night and Tuesday morning. And the Monday night interview was only aired once, in spite of this is a station which cycles the news every hour. They're running the same news every hour. But this one, I think it was a mistake. And actually, the young journalist who took me in, I don't know what happened to him. I think it was a mistake that I was taken in for this interview. But one of my friends recorded it, and this is the one which is now on YouTube, and it's got 250,000 hits now. The interview I did in the morning, we have held back because the first one took off so enormously. So better to keep the discussion in one place. And it's still getting 3,000 hits a day, which is enormous for me as a person. But the other interview is coming out these days. It's being Danish, English subtitles, and you can get the raw file if you want to put German subtitles on it. Okay. This is all.